Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about how to convert a given binary tree into double linked list. Our explanation is completely based on the assumption you already have some basic coding knowledge. If you are not good at basic coding, please visit our website learningmonkey.in, take the course placement training for service-based companies, then come for the competitive coding. Coming to today's class, given a binary tree, our task is to convert that into double linked list. The elements in double linked list should be in inorder traversals. Whatever the way you display the inorder traversal, the elements present in the double linked list should be in that order. The point, when you hear this point, the first point you get into your mind is yes, we need to implement inorder traversal. Yes, we need to do it. We can do it in two ways, using recursive functions and using loops. So our suggestion is try to solve it in both the ways. But here in this class we are going to give you the logic based on loops. Using recursive functions is very easy. It's just a 3-line code. So we are giving you an idea based on loops. You take the idea, implement both the ways for better practice. So the time complexity you have to maintain order of n, and space complexity should be order of h. H means height of the binary tree. Yes, whenever we are using implementing inorder traversal using loops, we need to create a stack. Stack should be of space. Minimum space required is the order of h, height of the binary tree. That is what needed. That's why space needed is order of h. So we understand from the basic in our data structures class, we discussed this logic when we implement the inorder traversal using loops. So let's refresh the concept once. Inorder traversal means left, complete the left, then display, then go to the right side. This is what the logic of inorder traversal. First, if you start from here, first complete the left. So that's why move left, move here. If you want to display this node, first complete left. Yes, moving here. If you want to display this node, first complete left. Left is none. So left is completed. That's why we are displaying 4. The first node we are going to display is 4. Then move right. Right is not there. Left completed. So that's why display 2. So in the double linked list, we will have the elements 4, 2. Now come to right side. Left is not there, so display 5. Right is not there, left completed. So go to 1. 4, 2, 5, 1. Move right, left. 6. 4, 2, 5, 1, 6, 8, 3, 7, 9. This is the way we are going to display in inorder traversal. So what's the logic? When we start from here, just move on to the left. We keeps on moving the left until you found none. Means left completed. That is the logic which we used. Move on left means we need to save the nodes in the stack. So repeat until the stack is empty. Move left until none. Whenever you found none, you have to move left. Whenever you are moving left, push onto the stack. So 1 is pushed onto the stack, 2 is pushed onto the stack, 4 is pushed onto the stack, and move left. Now if you move left onto the 4, it is none. Whenever you see none, means left completed. Whenever you see none, left completed. Now you need to display 4. If none, display. We need to display the node from the top of the stack, which is 4, and we have to move right. Means you have to take the element that present on node that present on the right side. That is the logic we used when we discussed the inorder traversal. We are going to use the same logic. Instead of displaying the node, if none, take the node from the stack, means pop the element from the stack and display it, move right. Instead of display, you create a double linked list there from this. So that is how we implement the logic. So the first node, whenever you are implementing the double linked list, you take a head variable and you take a previous variable. Why we need that previous variable? See here, the first node is 4. When you move to 2, this node address should be maintained in the right side of this node. That is what double linked list means. So this node address should be maintained in the left side of this node. In order to identify the previous node, we are using a variable called previous. Head node should point to the first node. So initially head and previous values are none. If head is equal to none, this similar logic, when we are creating the single linked list, we use the same logic. If head is equal to none, this is the first node. So attach it to the head. From next onward, if head is not none, you have to attach it at the end of the list. Similar logic, if you take the head variable, if it is none, means the first node should be attached to head. Remaining node should be attached at the end of the list. So we move on here. Whenever you see none, we take the element from the stack and we are going to attach it to the head. Now we move right side. What is there on the right side? None. Again none. This is maintained in a variable called current node. What is the current node when you move to the right side? None. If current is equal to none, again pop the element from the stack. Which one we are going to pop? After removing 4, which one we are going to pop? 2. So this is what? Display it. Means here we have to attach it for the double linked list. We need to maintain the previous node and attach it to the double linked list. Move right. Whenever you move right, what is the current node it is pointing to? 5. Push on to the stack if it is not none. 1, 5. Again move left. If left is none, take the node, move left. If left is none, pop the element from the stack. 5. Display it. This instead of display, attach it to the double linked list and move right. If it is none, display and move right. Here we know we are not displaying it. We are attaching it to the double linked list and moving to the right. Again right is none. So that's why if you take the element from the stack, it is 1. After removing 5, what's remain in the stack? It is 1. This is what the logic you have to implement. So until this should be repeated until the stack is empty. So coming to the coding part, we will give a brief idea on the coding part. Here we are taking this node, means we have to take a node value, so left and right and data value. So coming to the logic part, we are taking previous none, head is equal to none, and we are taking a stack, current is equal to root. If current is not none, stack dot append of current, put on to the stack and move left. Current is equal to current dot left, move left. Else if length of the stack greater than 0, current is equal to pop an element from the stack and attach it to the double linked list. If it is the first node, attach it to head, else attach it to the previous node. That's the logic. Attaching it to the previous node, else break. If the stack is empty, we are coming out of the loop. We are using a break statement to come out of the loop. So this is the logic you have to maintain. So coming to the coding part, anyhow the code is available in our website learningmonkey.in. Go to Learning Monkey and you can copy it and you can use it. Hope you understand this example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.